Section 1. Introduction to operating systems. Operating systems serve as the backbone of any computing environment. They act as intermediaries between users and hardware, managing resources and providing essential services. Without operating systems, interacting with computers would be a daunting task, requiring deep technical knowledge. Imagine having to manually allocate memory every time you open an application or write complex code to send data to a printer. Operating systems alleviate these burdens, abstracting away the complexities of hardware management. From the moment you power on your device, the operating system takes control. It loads the necessary drivers, initializes hardware components, and prepares the system for user interaction. Whether it's a desktop computer, a smartphone, or a web server, every computing device relies on an operating system to function. Section 2. Process management, the brain of the OS. One of the core functions of an operating system is process management. A process represents an instance of a running program. Every time you open a web browser, edit a document, or stream a video, you create a new process. The operating system acts as a conductor, managing the execution of multiple processes concurrently. It allocates processor time to each process, ensuring that all running applications receive a fair share of resources. This is crucial for maintaining system responsiveness and preventing any single process from monopolizing the CPU. To manage processes efficiently, operating systems employ various scheduling algorithms. These algorithms determine which process gets to use the CPU at any given time, optimizing for factors such as response time, throughput, and resource utilization. Understanding process management is essential for developing efficient and responsive software applications. Section 3. Memory management, juggling resources efficiently. Memory management is another critical aspect of operating systems. Just like a juggler keeps multiple objects in the air simultaneously, the operating system manages the allocation and deallocation of memory to different processes. When a program needs memory, the operating system assigns it a portion of the available RAM. When the program no longer requires that memory, the operating system reclaims it, making it available for other processes. This dynamic allocation and deallocation of memory ensures that the system's resources are used efficiently. Operating systems employ various techniques to optimize memory management, such as virtual memory and paging. Virtual memory allows processes to access more memory than physically available by using disk space as an extension of RAM. Paging divides memory into fixed-size blocks, enabling the operating system to swap data between RAM and disk as needed. Section 4. File systems, organizing the digital world. Operating systems also provide a structured way to organize and access files through file systems. A file system defines how files are named, stored, and retrieved on storage devices such as hard drives and SSDs. It creates a hierarchical structure of directories and files, allowing users to navigate and manage their data efficiently. Imagine a library without a cataloging system. Finding a specific book would be a chaotic endeavor. Similarly, without file systems, accessing and managing the vast amount of data stored on computers would be an insurmountable task. File systems ensure data integrity by implementing mechanisms for error detection and correction. They also provide security features to control access to files, preventing unauthorized modifications or deletions.